start with the first example right away. We have to draw a graph of the secant function. And in particular, we have to label all zeros, maxes, mins, and asymptotes and figure out what the period of the secant function is. So remember now that the secant function, secant of theta, by definition is 1 over cosine of theta. So a really good place to start here when you're trying to understand secant theta is with the graph of cosine theta. So let me start with a graph of cosine of theta. There's pi, there's 2 pi, and I'm going to extend this out a bit, 3 pi, and negative pi. Now remember that the cosine function starts at 1, goes down to 0 at pi over 2. So there's pi over 2. Goes down to negative 1 at pi. Comes back to 0 at 3 pi over 2. Back up to 1 at 2 pi. And the period of cosine is 2 pi. So it's repeating itself after 2 pi. So I'm not drawing secant yet. I'm drawing cosine of x. Y equals cosine of x. So in black here, I've got, we'll call it theta, cosine of theta. Now I'm going to draw the secant function in red. So that means we're doing 1 over cosine of x, or 1 over cosine of theta. So in particular, 1 over 1 is 1. And then as the cosine goes down to 0, secant is 1 over cosine, so it goes up to infinity there. And it does the same thing on the other side. So secant looks like that. When the cosine is negative, when the cosine is negative 1, secant is negative 1, and when the cosine goes to 0, secant blows up, but since cosine is negative here, secant goes to negative infinity when the cosine is negative. And then when cosine is positive again, secant is positive again, going up to positive infinity on both ends there. So that's what the secant function looks like. While the cosine goes between negative 1 and 1, secant is just the reciprocal of that, so it goes from 1 up to infinity and from negative 1 down to negative infinity. So now I've got the secant graph in red. Let me label all the things we've been asked to label. First of all, the zeros. Well, the secant theta has no zeros because it never crosses the x-axis. So there are no zeros to label. Maxes, all local maxes of the secant function. Well, here's one down here at pi negative 1 is a local max. Minimum at 0, 1 is a local min. 2 pi 1 is a local min. And so on. It has a local min or a local max every pi units. So we've got the maxes and the mins. The asymptotes are the places where the secant blows up to infinity or drops down to negative infinity. And so that's an asymptote at negative pi over 2. And at pi over 2, we have an asymptote at pi over 2. And again at 3 pi over 2. and again at 5 pi over 2. So basically every pi units we have an asymptote where the secant function blows up to infinity or drops down to negative infinity. Finally, what is the period of the secant function? Well, the secant function is really dependent on the cosine function, and the cosine function repeats itself once every 2 pi. The period of cosine is 2 pi. So the period of secant is also 2 pi. And you can see that from the graph. It starts repeating itself after a multiple of 2 pi. So that's what the graph of the secant function looks like. It kind of has these u's and then these upside down u's, really dependent on the cosine function, because the secant is just 1 over cosine theta.